The vector equation of a line. Following on from last lesson, we're now going to look at how we find the vector equation of a line and how we show that any given position vector is on that line. Firstly, we need to establish what we mean by this. Well, this is a vector like the vectors we found last lesson. If you remember, we looked at things like the vector AB with a given magnitude or length and a direction. If we look at the vector equation of the line, we look at where the line which goes through AB. So the vector has definite length magnitude, the line passes through and has infinite length. Like we've done before in coordinate geometry with the equation of a line and a line segment. In coordinate geometry, we use y equals mx plus c for the equation of a line, the equation giving us the value of y for a given value of x. The vector equation of a line is very similar. It must give us the position vector of any point on the line. If we have any 2 points in space, there is only one line that passes through them. So for example, if A and B are fixed points, and we consider other points on this same line, here we've got R1, R2 and R3 as 3 other points on the line, we need an equation that gives us any of these position vectors. So if we start with R1, we can see that we can write R1 as A plus, and that distance there, half AB. Now looking at R2, if this length here from A to R2 is double the distance from A to B, then we would write this as A plus 2AB. And in a similar way for R3, we can write this as A minus, or plus if you like, minus a quarter AB. Basically, like we did last lesson with this idea that we use this position vector and AB to describe. Remember, we did it for the midpoint, didn't we, last lesson? So what does this give us? Well, 3 equations for R1, R2 and R3, but for any position of R, so we had R4, R5, we would always get a similar equation. The only difference in the equation is this value here. So we call T a parameter. It can have any real value. It will be a scalar, it will be a number, it will be a multiplier. And this gives us a general equation for any point on this line. We know that we can calculate the vector AB from last lesson by B minus A. So we can think of the equation like this, which is useful when we're trying to work out what the equation is. This will give us the position vector of the point A on the line. This here will give us the direction vector AB. We used A in this example. We could equally have used B. It would have given us different, if we'd used B, it would have given us a different equation basically. So if we'd gone to R1 from B, it would have been B plus minus half AB, or to R it would just be plus AB. So it does change the equation a bit, but it's still in the form of a point on the line here plus a parameter times direction vector on the line. So in other words, the vector equation of a line isn't unique. But what it does achieve is it enables us to find any point on that line. So we could have used, instead of AB, any vector that's parallel to AB or collinear to AB on the same line. So for R1 here, we could have had A, position vector on the line, plus a half AB, or A plus a third P. So to summarise, the vector equation of a line through two fixed points A and B is given by this equation, which we can calculate like this. We can also use a vector that's parallel, like P in the example, and any fixed point on the line. So that's a position vector of a known point on the line, and this is a direction vector of the line, of a line parallel to the line or collinear. We generally use, well, probably most commonly, lambda and mu for our parameter, but we also quite regularly use S and T. Essentially, we can use more or less anything as long as it doesn't conflict with any of the other letters that we're using in an equation. But this is what we tend to do, and we tend to use R to signify the point, the general position vector. Okay, let's work through some examples. So find the equation of the line that passes through A and B. Well, this one's straightforward. We just use the equation to find the direction vector. We're finding AB, aren't we? So we just subtract A from B. And then we can use either point on the line here. So this is the point on the line, so we could have used either A or B, plus the parameter T times B minus A. So it's just slotting into that formula. Because the R are X, Y and Z values, we can do this. This minus 3 plus t times minus 5 will give us our x value, 4 plus 5t our y value, and 1 minus t our z value. So that's the same thing. There we're just using a different point, aren't we? But we would change, as we showed before, if we use B instead of A, it does change the value of T. If T is equal to 2 here, then we get 2 minus 10 gives us minus 8, minus 1 plus 10 gives us 9, and 2 minus 2 gives us 0. In the second version, to get the same value, because that point will be on the line, so it must be possible, we would have t as 1. So now to find the vector of equation of a line passing through this point and parallel to this vector. Well, this is really easy. We just need to remember that we need a position vector, we've got that, and we need a direction vector. Well, one that's parallel is perfect, so we can just use that vector. So it's as simple as that. So we just put our position vector and our direction vector in there. To show that a point lies on a line, the first thing we do is we say, well, we have to have a value of t that will give us this x value. So to get 7 as our x value, we would need t to be -1. So we need 2 plus -5t to equal 7. So t has to be -1, and we can see here how we can work it out. This t value now must give us these points here. If it doesn't, then the point won't be on the line. So we need to check those points next. So our y value works, doesn't it? And for z, the z value works as well. So we've now shown that the point's on the line. So since all three equations are satisfied, C must lie on the line. Okay, here's some for you to have a go at. Same as with any of the other videos, have a try, make sure you understand it. If you're successful in answering the questions, then you'll be ready for the lesson. Otherwise, go back over it or look it up on My Maths or look in the textbook or whatever it takes to make sure that you understand before the lesson. Good luck. Okay, solutions. So there's the solutions to the first part. And to question 2. So we've shown that the point doesn't lie on the line.